this implementation. Now here flip-flop can be implemented using NOR gate, or it can be implemented using NAND gate. So here in the left hand side you can see that the RS flip-flop is implemented using NOR gate, and then right hand side it is implemented using NAND gate. Now here in the truth table you can see that this flip-flop, as per the circuit there is two output, Q and Q bar. So this, if the as per the truth table you can see that if the SR value is 10, then QQ where is also 10. So here the set reset means if set value is 1, then the Q is 1. If set value is 0, then the Q value is 0. Okay. Now in case of 0 0, there is no change. If there is 1 1, then there is 0 0 in Q and Q bar. Okay. Now here in the third truth table means this selected truth table. Here the Q state is represented in respect of timestamp. Means what? At timestamp t, the memory cell means that now this single flip-flop can be uh, taken as a single memory cell where the output means Q is representing the current state. Okay. So here the Q is 0 and the SR is 0 0, then QT plus 1 is also 0. Means what? The state is not changing. Whereas when the Q is 1 and SR is 0 1, then the state is changing from 1 to 0. Means the memory value is changing from 1 to 0. Now here in this particular truth table, here you can see there is two cases where the RS values are SR values are 1 1. Then for 0 state as well as 1 state, the QT plus 1 state is intermediate. Means what? It is not determined. Either it is 0 or 1. It is not perfectly determined. So to overcome this situation, JK flip-flop is built up. Now JK flip-flop is a gated SR. Here you can see this SR. This in this logic diagram, you can see there is a formation of 8. Formation of 8 means what? That output of this upper NOR gate is taken as a input to the lower NOR gate, and the output of the lower NOR gate is taken as an input for the upper NOR gate, and it is a formation of kind of structure 8. Now this is a latch. Now SR flip-flop have this particular problem where it is 1 1, the next state is not it is not possible to determine the next state perfectly. It is an intermediate state. So to overcome that, there is another kind of flip-flop, that is JK flip-flop. Now in JK flip-flop, this is a gated SR. Gated SR means what? Here you can see that this latch part means this 8 pattern, the logic diagram, which is reflecting a 8 structure. That part is there, and that is the latch part. That is the main thing. And before that, there is a set of NAND gate is there, and this is nothing but a gated SR. Now JK flip-flop is nothing but a gated SR, and here also this clock pulse is whenever the clock pulse is high, then the state change. So here you can see in the truth table for JK means 1 1, for 0 state and 1 state where the Q is 0 or either 0 or either 1, the QT plus 1 is correctly determined. So when it is 0, Qt plus 1 is 1. When it is 1, Qt plus 1 is 0. So here the problem of this intermediate state of SR is overcome by JK flip-flop. Now, here this is a clocked RS flip-flop. Means state change only when the clock pulse is 1. JK, this is also a clocked one. Here you can see in the circuit diagram. Now in JK flip-flop there is a problem that is called race around problem, race around condition. What is this race around condition? In case of 1 1, the truth table reflect that if the state is 0, it will be changed to 1. If the state is 1, it will be changed to 0. Abhilash, why you are late today?
So actually, I was trying to join with my phone, but I couldn't, so I came up with my PC. It took some time, sir.
Now, mute yourself. Now, here the race around condition is a condition which arises when, say, this particular selected diagram, when the clock pulse TP, width of clock pulse TP is quite high, then the particular propagation delay. Propagation delay means what? That you give a clock pulse here at the input, and set the JK values are also given. Now here from this input to output, whatever the delay from this to NAND gate, here there is for J, it will going to traverse 2 NAND gate, K, it will going to traverse 2 NAND gate, and then it will going to determine that if the previous, whatever the previous value of Q, next value of Q will be determined as per this truth table. Now here you can see that when the J and K is 1 1, then there is a state change happen, means what? 0 to 1 and 1 to 0. Now in this particular lower diagram which is reflecting the width of the clock pulse and the width of the propagation delay, if the propagation delay's width is quite less, now if the propagation delay is quite less than the clock pulse, then the output Q will toggle, means it will oscillate. Means try to understand that your input is same, your clock pulse is still high. Clock pulse is still high means, say here Q is clock pulse is high, means during the high clock pulse the state only change. So clock pulse is high, but the propagation delay is less. As the propagation delay is less, then this Q value will be oscillate. Means what? for fast propagation delay, it will change. If it is previously the state is 0, it will change to 1. Then again here in the truth table you can see that uh, if it is 1 and the clock pulse is also high and the jk is 1 1, then it will going to state will be changed to 0. So then the state will be changed to 0. So now ultimate state means what will be the ultimate value of qt plus 1, that is ambiguous. Okay, so that to overcome that thing, we need the concept of master slave jk flip flop. So in case of master slave jk flip flop, there is two set of gated SR. One is fast set, that is the master JK. Another is slave flip flop, that is another JK flip flop, that is slave JK flip flop. Now here the circuit logic diagram is designed in such a way that the clock pulse, now if the clock pulse for the master is high, then the clock pulse for the slave will be low. Means what? Here in the first level of NAND gate, you can see the clock pulse, whatever the clock pulse is given. In the third level of NAND gate, the clock pulse is given in an inverse manner. So it will be inverse of that. Now, one thing you please understand, that this dotted line is the separation between master and slave, and this master output of master is given as a input to the slave. Now what this particular thing is doing, what this particular master slave is doing, it is actually increasing the propagation delay. Means what? Instead of 2 NAND gate, if there is 4 NAND gate, then the propagation delay will be high, and then this race around problem can be solved, because your propagation delay will be almost same as your clock width. Then this oscillation between 0 and 1, when the jk value is 1 1, will not happen. That is the basic concept. Now although it have some advantage over the normal jk flip flop, other advantage also. Now here in this particular master slave jk flip flop, there is 2 latch. Means what? 2 8 like structure. Here the first 8 like structure means the first SR, and for the master, and the second 8 latch for the slave. Okay, and here output means q is given as a input to the first level NAND gate, and q dash is also given as a input to the first level NAND gate. Now here first level NAND gate, in this case we need 3 input NAND gate. So in the simulator, here you can see that if we, in the component drawer, there is several set of category of component. Now in component drawer, here in the NAND gate, there is a arrow. Here you click on that arrow, then you will get 2 options: 2 input NAND gate, 3 input NAND gate. Now in bracket, when NAND gate in bracket 3, that means that is 3 input NAND gate. Now this circuit, the first level NAND gate required 3 input NAND gate, rest are all 2 input NAND gate. Okay. Now here but this master slave jk flip flop still have some
To
problem.
make all the circuit,
Huh?
We can just under sequential circuits in
Hmm.
the GUI, we can use directly the flip-flop IC chip from there, or we'll have to create using language.
No, here for this design T flip flop using JK flip flop, you
Hmm.
need to use the basic gates. Okay, means NAND gate. Okay, and
Oh,
for the synchronous up down counter and shift register, obviously you are going to use the module. Means what, the particular flip flop module. Say in shift register it will be D flip flop. In case of up down counter it will be JK flip flop. Okay. So I will show you the sample circuit uh, after completion of my discussion on the JK flip flop. Okay. So here, any more query?
no, no.
Okay. Now here, in case of this uh, master step JK flip flop, it's have a uh, problem, that is, you can see, normally we know that when the wire connection color is blue, that means 1, color is black, that means 0, color is maroon, that means unknown. So here you can see that lots of unknown color wire, that means those values are unknown. So let me show you a JK circuit. Here the master slave JK flip flop. Now here one thing I want to say, that here I have used only 2 input NAND gate. That's why there is one extra label, means one extra Pradyum,
Yes, sir.
you please mute yourself. Now here in this particular, here you can see that it's the status is as same as this particular circuit, means lots of maroon wire, means what, those are unknown. Okay. Now here unknown means the bit display will going to show you X. Okay. And here you can see that we are giving clock pulse. Here the clock bit switch, left bit switch is representing K, and the right bit switch is representing J, and the middle one the clock pulse, free running clock.
So just a question,
Yes,
to
yes.
complete the first one, design T flip-flop using JK flip-flop.
Hmm.
We will be using a master slave JK flip-flop or a normal JK flip-flop.
You are going to use the master slave JK flip flop, means this circuit. Okay. uh, Only difference will be that here I have used 2 input NAND gate only, but here in the you are going to use 3 input NAND gate, like this one. Okay. Here you can see in my circuit I have take 10 NAND gate. Why I have take 10 NAND gate? Because I have only used 2 input NAND gate. But here in this circuit, that initial circuit before the case analysis, or the other circuit also after the case analysis, here you can see 8 NAND gate are there. 6 NAND gate are 2 input, and 2 NAND gate are 3 input. Okay. So you have to use this particular master slave this particular circuit is a master slave JK flip-flop circuit, you have to use the master slave JK flip-flop circuit, because otherwise there will be a race around problem. Still race around problem will there, but you will follow this master slave design, okay, not the normal JK. Now here, if I change it, so let me change the circuit with 3 input NAND gate, so it will be clear to you. Instead of use of this two input NAND gate, I will going to take 3 input NAND gate here. And here the connection will be much more simpler, because here we are using the 3 input NAND gate, so less number of gate will be used. Now here in this first level 3 input NAND gate, the bit switch from the clock JK, both are given as an input to the 3 input NAND gate, and the clock pulse. And other than this, you have to give the Q, means the right side output. The Q will be given as an input to the left one NAND gate, and the Q bar will be given as an input to the right NAND gate. Okay, so here let me save it. MS master slave JK is also there, already there, so I take the name master slave JK1. Okay, another sorry, another things I have to do, that this NAND gate output, the input NAND gate output will be given to the input as a fast latch, means the latch of master. Okay. Initially, most of the wire are unknown. Okay. So again, if I use the same file name, it will going to replace the previous one. So here, in case of when you are saving the logic circuit, you didn't need to give the extension. Dot logic will take in automatically. Now if I select the clock and I start the clock, now you can see previously this clock values, means now clock values is changing from 0 to 1 now, but still lots of maroon were, and in the bit display I am not getting the 0 or 1. So this is because of inconsistent initialization in case of JK flip-flop. It is hanged, so I have to cross the circuit. Now, so this inconsistent initialization can be overcome by case analysis. Means what? This, when lots of maroon wire is there, that means it is the before the case analysis. Now, after the case analysis, here you can see the wire connections are either blue or black, means either 0 or 1. There is no such unknown condition is there, means no maroon wire is there. So here the when the Q bar is 0, that is also a case of inconsistent initialization. But when the Q bar is 1, that is the case of proper initialization. So here the circuit which we have created just now. Now here you have to click on this particular do case analysis button. Then this blue star will appear. Okay. Then you click on simulate. Then here there is a particular option, resolve unknown. Resolve unknown means X. Resolve unknown by gate simulation. You click on that option. Now then you click on clock and start the clock.
Initiate again, sir.
Initially,
The unknown clock, unknown simulation.
you here you start the clock. Okay.
Yes.
Now your selection should be on this. Means you click on do case analysis, then the star will be the selection should be on this blue star. Okay. Then you click on resolve unknown by gate simulation. Okay. Then you select the clock. Clock is already in running state.
Okay.
Simulate. Must. Okay. Simulate is going on. Do case analysis. Okay, let me show you this with the another circuit. The circuit is okay. I will check it and let you know that what the problem is happening. So here the two input NAND gate. Here also the circuit is as same as the previous. Now here you start the clock, then you simulate, then resolve unknown by gate simulator. Now here you see that still the race around problem is arising. Why the race around problem is arising? Because the propagation delay is less than the clock pulse width. Okay, means although the number of NAND gates is more, but still the race around condition is arising. So this race around condition means it is not only depend upon the propagation delay. This race around condition means where the in case of race around condition will going to arise when the particular propagation means your clock width is higher than the propagation delay. Okay, so here you can see whenever multiple times the message is coming that the race around condition in the circuit. Here you can see as well as Q bar, both are 1, but that is not the expected output, because if Q is 1, Q bar should be 0. Means that particular in case of, if you see the particular truth table, now here you click on OK, then again the clock will run. Now here if we, now here you can see that Q is 0 and Q bar is 1, and there is no such unknown, means there is no such unknown unknown case, means no wire color is maroon, all wire color is either 0 or 1. Okay, now here in the this 2-bit display which I have taken from the master, taken as the output of master, it is not mandatory. Here you can see that in this circuit there is no Q bar is the main thing, means the final output. But here to check the particular status of output of master, I have take this 2-bit display. You take or may not take, but here the important thing is that here to resolve this case unknown thing, means what, if initially if I load this circuit and then I start the clock, sorry, so here this simulator have the problem, sometimes it hang. So here one thing you please remember, that when you are loading a circuit, the clock should be uh, means the clock should be in stop state, means what, that when this start clock button is disabled, that means clock is in running state. So if you click on stop clock, then this clock start clock will button will enable. That means the clock is not running now. So you at that stage you load the circuit, and here you can see that lots of unknown is there. Uh, we start the clock, still the lots of unknown is there, means the 0 and 1 it is changing, but the bit display are not showing either 0 nor 1. So we stop the clock, or it is better that uh, clock is in running state, you click on case analysis, then you click on simulate, then you click on resolve unknown by gate simulation. So here you can see after this the race around condition is appear, but this all the x are now either 0 or either 1. Okay, now to stop the clock. Now one thing all of you please remember, that the clock, when the selection is clock on clock, then only the clock will change. When the selection is not on clock, clock will stop. Okay, so here the selection is clock, you stop the clock. Okay, now here in the other circuit, means that MSJK1, where I have used, so here you can see I have used only 2 input NAND gate. Now in case of other circuit MSJK1, here the the particular X are not resolved, so we simulate, then do the gate by gate resolve. Now after we do the gate by gate resolve, here you can see that the value is no, there is no such X, all are either 0 or either 1. Okay, so you build up the circuit using 3 input NAND gate, then the circuit will be simple. When the clock is running, the selection should be always on the clock. Okay. But here the problem is that circuits 0 1, it is always in 0 1. So if I change it, the bit value means 1 1, then the values are changed. Okay, so here it will going to toggle, means what, 1 time 0, 1 time 1. Okay, and if the both the bit switch I make it 0 0, then again it will going to, there will be no change. So here this circuit is okay. Now okay, it is already there in, I have saved it already. Now if you have any question up to this, you can ask. Now to overcome this race around, this particular improper initialization, there is a particular concept of set, inverse clear and inverse clear and inverse preset. Now inverse clear and inverse preset circuit is like this, that in the first level there is a 2 input NAND gate, and the second level also there will be 3 input NAND gate, and in the latch of the master there will be that will be also 3 input NAND gate, and the preset values are given, means whatever the preset values, it will be given using a NOT gate to that particular NAND gate, and whatever the clear value, it will be given via the NOT gate to that particular NAND gate. So if we take uh, that preset clear JK, I have created a preset clear JK. This one is a preset clear JK, but here the circuit is little bit complex, because not the complex, all the things are very simple because you can do it by only drag and drop. So here the I have used only 2 input NAND gate. That's why the number of NAND gate is more. But here you are going to use the 3 input NAND gate. In the first level, 3 input. In the second level, also 3 input. Now, if I make the JK11 and then I okay. clock is in running, that's why it's hang. So here again, as I told you, that when the uh, initially when you loading the particular circuit, the clock should be is in uh, stop state. So preset clear JK. Here both are 1. Now here you can see from the Prodyum. Mute yourself, please. Now here all the bit displays are X. I start the clock. Clock is running. Now here you can see that we don't have to do that particular case analysis. Means what? The case analysis is there in the means we don't have to click this, means we do not need to do this gate by gate simulation to resolve unknown, or click on this do case analysis, because as we are using the inverted clear and inverted preset, the situation, the improper initialization situation. Improper initialization means what? That lots of unknown is there. Bit display are showing X because the unknown. Okay. So here, in case of preset, and when you are going to use the clear, inverted clear and inverted preset, then it will be the case analysis is not required. So here, when you are going to do this particular assignment, means T flip-flop using JK flip-flop. So here you use this preset and clear so that this initialization problem is not appear. But you can use this normal. You may not use the preset and clear. You take the only the normal JK and do the case analysis. That will also going to solve your problem. Okay. Preset
Sir,
and clear.
but you already told that we should use master and slave one.
This one is the master and slave.
But sir, it is also preset and clear. Sir, do we have to use that?
Preset and clear, use or may not use, that is not a issue, but you have to use the master and slave JK.
Okay, sir.
But when you do not use the preset and clear, you must remember that you have to do the case analysis and the uh, resolve unknown by gate simulation. Now here you see that the toggle flip-flop. Toggle flip-flop is mainly just toggle that particular state. Means if the QT is 0, then when the T is 1, then the output will be QT plus 1 will be 1. Means it is changing from 0 to 1. And when the when it is 1 and the T is 1, then it will be changed to 0. And in case of T is 0, there will be no change. So to do that, you need to modify. Here you can see this D flip-flop. This D flip-flop is a case of that it will not going to toggle. Means what? Whatever the your input, in case of D equal to 1, whatever your, in case of D flip-flop truth table. Here you can see that D flip-flop, when D is 1, then in case of 0 it is become 1, and in case of 1 it is still 1. Means what? There will be no change. Okay, means 1 should not be changed to 0. Toggle means 1 will be changed to 0. So here in case of D flip-flop, what we do, we need to, here in this JK flip-flop circuit, if I take that 3 input JK flip-flop circuit, here in case of D flip-flop, whatever you give the input as a J, means that is D, inverse of that will be taken as an input to the another NAND gate, another 3 input NAND gate. So here in case of toggle, you just use your common sense and then do the necessary change, or you can get the circuit from net also, that T flip-flop using JK flip-flop. Now,
I think for T flip-flop, using JK flip-flop, we will make we make both the inputs J and K same, then it should be acting like a T flip-flop.
okay, so that means you don't need to use this NOT gate. Okay, whatever you are giving the input to the first NAND gate, that will be also given as an input to the second NAND gate. Okay. Now, okay, this particular flip-flop D is based on single JK, but you have to create a master slave JK and give the particular input for the both the first level NAND gate. Now for the next two assignment, first we are going to see the shift register. So in case of shift register, it is shift register or counter. These are kind of memory, means sequential circuit which mainly used for some special, say, register. Register are the memory element for in the CPU. Means all of you know that inside the CPU, whatever the memory element, that is register. So how to build up this register? So this register can be built up using either any of these particular flip-flop. Okay, SR, JK, D, T. Now counter is a special case of register. Means what? Counter in case of register, say here, this is a 4-bit serial in, serial out. Serial in means what? Data input is given to D. Here the D flip-flop is used. So given to D, and the output is also taken from, means in between there is no output. The output is coming from the last flip-flop. Okay, here this is a 4-bit. 4-bit means we need 4 D flip-flop. Serial in, serial out means input will be given at the first D flip-flop, output will be available at the last at the queue of last D flip-flop. Here you know that the input is D and the output is Q. Now, in case of serial in, parallel out, the input will be given to the D, but output will be the output for from each and every flip-flop. Means output of first D flip-flop, second D flip-flop, third and fourth. So all the output you are going to show in the bit display, and that will be Now in all this register case, so let me show you a example of serial in parallel out 4-bit shift register. Here 4-bit serial parallel register. So this is the case. Here I have used the D flip-flop. So here in the component drawer, you can find out that in D flip-flop, if you click on this arrow, there will be 4 options: D flip-flop from SR, D flip-flop from JK, D flip-flop in preset and clear, then master slave D flip-flop. So you take this particular D flip-flop from JK, and if you click on that, you take the chip, you can see the pin configuration. Here you can see that the clock is given at the pin number 8, and the input is given in pin number 5, and Q and Q bar is there in 4 and 1. So this circuit means this 4-bit serial in parallel out. This particular 4-bit circuit is used to build up this particular 4-bit 4-bit serial in parallel out shift register. Shift register means what? The bit value will be shifted when the clock pulse is high. That is the main concept. So here you can see that here the Q is there in the particular pin 4. So here all the Q is 0 now. So let me change the bit switch, means change. Here it is serial in parallel out. So first the input will be given only to the first D flip-flop. So I change it to the 1, and then I start the clock. So if I start the clock, here you can see the bit value will be when both Q bar is 1. That is not the case, because that is not the proper output. Here you can see that 1 is shifted from this first D flip-flop Q to last D flip-flop Q, and now all are 1. Okay. So here in register the shifting happen, and after shifting happen, again if I change it to 0, then again you can see from first D flip-flop Q to last D flip-flop Q, the 0 will be propagated. Okay, means sorry, 0 will be shifted. Now once the shift is happen, then there will be, that will be fixed. But in case of counter, so let me stop the clock. In case of counter, the here, say for example, a ring counter. Okay, although you have to do the up down counter, in ring counter what happened, that one pattern is Onmesh? Onmesh, are you there? Onmesh?
Yes, sir.
তুমি 10টার সময় কেন এন্ট্রি করছো? তোমার 9টা থেকে ল্যাব। তারপর তুমি তো গ্রুপ 2 স্টুডেন্ট, সে নয় ঠিক আছে, এই ল্যাবে তুমি অ্যালাউ করলাম, কিন্তু তুমি 10টার সময় কেন ল্যাবে এন্ট্রি করছো? তোমার 9টা থেকে ল্যাব, আর তুমি ল্যাবও ঠিকঠাক করো না গ্রুপ 2 সময়, গ্রুপ 2 টাইমিং এ। এরকম চলতে থাকলে কিন্তু তুমি ফেল করে যাবে, হয়তো তুমি ফেল করেওছো আগের সেমিস্টারে। এনিওয়ে, Okay, so here in case of register, the bit value will be shifted only, but in case of counter, the bit, there will be a pattern will be shifted. Means what? Say in case of this ring counter, this pattern is shifted. Means what? That initially the ring counter is uh, serial in 4-bit. Here it is 4-bit synchronous ring counter. So the pattern is circulated when the clock pulse is applied. Now initially say the, here you can see the serial in parallel out. So here the initially the pattern is 1000. Okay. So next clock pulse, the pattern will become 0100. Means what? This one is shifting from first D flip-flop Q to second D flip-flop Q, then again third D flip-flop Q, and again here you can see the last D flip-flop Q is given as an input to first D flip-flop D. Okay. So it is forming a ring, and that means what? When 000